Okay, so what is inverse function? So the definition for inverse function. So first of all, we need to think about what kind of equations can have inverse function. Okay, what kind of equations will have inverse function? So first of all, you need to remember, when we talk about inverse functions, that must be a one-to-one function. If that's not a one-to-one function, cannot find inverse function. Okay, the word inverse here means you swap the value for x and y. So what is inverse? Say we have a machine here and you put some value x in and that will give you some value y out. For example, the calculation inside is 2x plus 1. You put 1x and you will come out with some y values. And that's say fx. We introduced the concept for inverse calculation. Okay, so inverse of that. So there's the inverse function. So what is an inverse function? An inverse function means you take the result. Okay, so what you have here, you take the result to put into this function after some kinds of calculations that can give you the original x you put in. It's kind of reverse way to calculate your numbers. Okay, you have 1, you put 1 into this machine that will produce 2 for you. But for this machines, you put the 2 in that will produce the 1 out for you. Okay, it's a reverse way to calculate things. It's not only true for one point, it's true for all the points. Say if you have 1, 2, 2, 3, 3, 4 for the fx function, which means you put 2 in, you must have 1 out. You put 3 in, you must have 2 out. So that is the inverse function. So an easier way to represent inverse function will be, say y equals to fx. Then your x must equals to fy. Okay. After some kinds of calculations, you put y into that function that will give you x out. So that is the original, and that will be the inverse. Okay, so inverse functions basically change the position for your x and y values. And think about that. If on my original function I have 1, 2, then on the inverse function I must have 2, 1. If on the original function I have 5, 3, in the inverse I must have 3, 5. So all the coordinates will be swapped for x and y values. Okay, so I put a diagram. I'm not sure if you can see it clearly, but I will just sketch here. So if I have a point here, then the corresponding one on inverse must be this point. If I have a point here, then the inverse must got a point here. If I have a point here, okay, the inverse must give me a point here. And if I have a point here, then the inverse must give me a point here. So if you can find that, that must be symmetrical along the line y equals to x. Y is symmetrical about y equals to x because you change the xy coordinates. So 1, 2 become 2, 1, 3, 4 become 4, 3. So it's symmetrical about the line y equals to x. So that is inverse function. So original function and inverse function will be symmetrical about the line y equals to x. And you can see this diagram is much clearer. So you have the blue one is the original one, the inverse one you call f minus 1. Okay, f to the power of minus 1. So the yellow one will be the inverse, and it's symmetrical about the line y equals to x. Okay, so that's the definition for inverse function. So why, come back to this question, why only one-to-one functions can have inverse function? Okay, because you have inverse, then the domain of the original function will become the range of the inverse function. The range of the original function will become the domain of the inverse function because you put the range into the inverse function to get the domain of the original one. So basically, we have this. Okay, so the domain and range will totally swap for inverse and original one. So the dom of f, so domain of f will be the range of F inverse. And the range of this F will become the domain for the inverse. Okay, because all the coordinates change the order for X and Y. So the domain will become the range will become the domain. And now think about this. If you have a many-to-one function, okay, if I have a many-to-one function, this many means the domain, and this one means the range. Okay, now you swap the X and Y values. That will become a one-to-many. But that's a relation. That's not a function anymore. So if that's not one-to-one, after you swap the X and Y, that will become one-to-many. If it's one-to-many, then it's not a function. This exercise is called the inverse function. But if you got a many-to-one at the beginning and you swap that, that will become one-to-many. It's not a function anymore. So you cannot have an inverse function for a many-to-one function. Okay? You cannot have the inverse function. But you still can find inverse. Okay? You still can find inverse, but that's not a function. Okay? You can say that's an inverse relation, but that's not an inverse function. Any graph has been reflected by the line y equals to x can have an inverse relation, but only the one-to-one function can have an inverse function. Okay, does that make sense? Okay. So many-to-one, if we have a many-to-one relation, if I have many-to-one, that must be a relation. Then the inverse must be a one-to-many. Okay, so that's a function. And then you have a one-to-many, it's a relation, that cannot be a function. So that's why only one-to-one functions can have inverse function. Okay, so that's all the definitions for inverse. Okay, that's all the definitions for inverse. So what's the key features for inverse? So a function can have inverse function if and only if it is a one-to-one function. F inverse graph is a reflection of fx by the line y equals to x. And the domain of F inverse will become the range of F, and the range of inverse will become domain of F. Okay, so that's all these definitions here for inverse function. So now I give you an original function and I want you to find out the inverse. Okay, I want you to find out the inverse. So how we can find out the inverse? That's the 6 steps you need to follow. Okay, that's the 6 steps you need to follow when you have an original function ask you to find inverse. So if you follow the 6 steps, you can work out any single questions. Okay, so just need to remember the 6 rules. So first thing we need to do is state domain of fx. Okay, state the domain of the original function. Number 2 is state the range of the original function. Okay, state the domain, state the range. Number 3 is swap the xy. Okay, if you have x, you write that as y. If you have y, you write that as x, because inverse function is swapping x and y values. And number 4 is make y to be the subject. Rearrange your equation to make y to be the subject. And number 5 is state the domain of F inverse. But the domain of F inverse will be the same as the range of F you already stated in step 2. Okay, just rewrite it down. So dom of F inverse equals to range of F, which you repeat the value in step number 2. And the last step will be state the range of F inverse, which is the domain of your F, so which you repeat step number 1. So to say that's a 6 step, it's actually only 4 steps. Okay, only 4 steps. You just need to repeat the things you have above. So that's the 6 method. Okay, 6 steps you need to find inverse functions. I'll show you some examples, but you need to now remember what's the 6 steps. Okay, follow the exact order. Find the domain of F, find the range of F, swap xy, make y to be the subject, restate the domain of inverse, and restate the range of inverse. Okay, that's the 6 thing what you need to do. So let's have a look at question 1. Okay, let's have a look at question 1. So in question 1, I want to find the inverse function for this. Okay, do you remember that can become a function as well, but there are only 4 points in this set. Okay, this is a set. And what is a relation? A relation is a collection of order pairs. Okay, remember this definition? Set is a collection of order pairs. This is a relation, and it's also a function because it's one-to-one relationship. Okay, 1, 2, 3, 4, 5, 6, 7, 8. That's a one-to-one function as well. Okay, if that's a one-to-one function, I can find inverse for that. But for this type of question, because it's only a collection of finite many of order pairs, we are not going through those 6 steps. So it's very easy for this one to do, because what I need to do is just swap x and y. Okay, 1, 2 will become 2, 1, 3, 4 will become 4, 3, 5, 6 will become 6, 5, and 7, 8 will become 8, 7. That's only 4 order pairs, and what you need to do is just swap the x, y orders, and that is still 4 points on the inverse function. Okay, that is still 4 points there. I have 4 points here, and I will reflect by the line y equals to x. I still got 4 points, and those 4 points will be the inverse relation. Okay, it will be the inverse function. And the domain of that will be curly bracket 2, 4, 6, 8. Okay, I see before like students write this 2 to 8 is not true. Okay, 2 to 8 or like round bracket 2 to 8 is not true, because 2 to 8 means all the values in between 2 and 8. Okay, round bracket, all the values in between 2 and 8, not including 2, not including 8. But for this type of questions, so you have only 4 points is your domain. So use a curly bracket. You use a curly bracket. So what's the range? The range is 1, 3, 5, 7. That is your range. Okay, 1, 3, 5, 7. So that's example 1, which is really easy, but like students can a little bit confused when they see this question, like say what I should do. There's no rules here. I only have points. So if you have points, that's the easier case. You just swap the x, y orders, and you have another 4 order pairs, and which is this relation. Okay, example 2 will be what we need to do for the 6 steps here. So for example 2, I want to find the inverse function f inverse of this function. Okay, of this function. I want to find inverse for that function. And then I want to state the domain and range for that inverse function, and I want to sketch this fx and f inverse x on the same set of x's. Okay, now let's sketch the original function first. Say we have fx equals to 2x minus 3. Then 0 minus 3 must be 1 point here. And then let's make y equals to 0. So that equals to 0. 2x equals to 3, x equals to 3 over 2. So you have 1.5 here. Okay, so you have, that's a linear function. You have x, y coordinates, and I will connect them by a straight line. So that is the original function. So you need to label 3, 2 here, and 0, -3. And you need to label this function because you are going to sketch another one. Okay, you are going to sketch another one. So now, like, think about this question. Every single coordinates will be changed the order for x and y. Then now I have fx have a point 0, -3 here. What will be the coordinates on the inverse function? You have 0, -3 on your original equation. What will be the coordinates on the inverse? -3, 0, right? You will swap x and y. So you will definitely know that -3, 0 must be on the inverse. And similarly, we have 3 on 2, 0. So what will be the coordinates on the inverse? What will be the coordinates on the inverse now? Yeah, you swap that, 0, 3 on 2. So 0, 3 on 2 will be here. Okay, so you can find another 2 points because that's a linear and really easy to sketch. And I will have negative 3, 0 is here. And we have 0, 3 on 2 is here. Have a point like this. So that's 0, 3 on 2, and that is negative 3, 0. Okay, so that's the F inverse X. Okay, that's the F inverse X. Okay, so the next thing what we're going to do is 0.5, and we're going to find the rule for that. We just find out the graph by using 2 points, and which will be correct, but like what we don't know the rule yet. So to find the rule, I will say repeat all these steps for the 6th step. So step number 1 will be state the domain for your F. So dome of F will be R. Because it's a linear function, all the domain can take, which is R. Step number 2 is take the range of F. The range of F will be R as well. Okay, because it's a linear function, I can have R as well. Oh. Have R as well. And then the next thing is swap the X and Y. Okay, step number 3 is swap X and Y. So when Fx is same as Y, right? When you see Y, you write that as X. You see X, you write that as Y and minus 3. And then what you do is step number 4, rearrange the equation to make Y to be the subject. So that's X plus 3 and Y equals to a half X plus 3 over 2. And you can see here the y-intercept must be 0, 3 on 2, and we have 0, 3 on 2 here. Okay, step number 5 will be repeat the domain for F inverse. So the domain for F inverse will be the same as range of F. Okay, the domain and range will swap. So domain of F inverse will be range of F, which is R. Number 6 will be what is the range for F inverse, which will be the domain for the F, which is R as well. Okay, so let's write this rule in function notation. So remember what is function notation? You have the name of that function, which is called F inverse. Okay, the name of this function is called F inverse. Such that, what is the domain? Domain is R, and mapping to R, comma, will be the fixed notation. You repeat the name of that, and you talk about what is the variable. The variable is X. So F inverse X will equals to a half X plus 3 on 2. A half X plus 3 on 2. Okay, so that is in function notation, what is the inverse function? So that's question number 1. And let's have a look at question number 2. State the domain and range for the inverse function. State the domain and range, we have it already. So domain of F inverse is R, range of F inverse is R as well. And question number 3 will be sketching the graph. We have sketched that on the first step, but what I will sketch is a line y equals to x. That is y equals to x. Okay, so can you see this graph is symmetrical about this y equals to x, this line? Okay, can you see this point of intersection? There's a point of intersection here. Can you see the point of intersection here? How can we find out this point? How can we know where they intersect? Simultaneous of which two? The inverse and the original one. You can work out by this way, and it is correct. but there will be an easier way to find the intersections. Okay, you can work, because this question is easy, it's two linears, and it's easy to find the intersection. But let's think about when we learn like more things, and we have, say, quadratic. Okay, we have one quadratic, and then we find inverse for the quadratic is still like, let's say it's a square root function, and you have a square root, and you have quadratic, and you want to find the intersection. It can be really hard. Okay, it can be really hard. And in year 12, later in the year, we'll learn exponentials, and the inverse will be logarithm. And logarithm and exponential is really hard to find point of intersections. And some of the question, I see one question in VCA papers. They give you two equations, and which is really difficult. Okay, really complex ones, and you can find inverse. Okay, one is exponential and the other one is logarithm. And you put that, I put that into the calculator. I show my students, I put that into the calculator. What I want to show them is, can you see that how much of the time you use to put those two equations? And I put that in and press enter. What I find is the calculator gives me no values. Okay, so it's two correct equations and I find no values. Why that happens? Because calculator is not that smart than what you think about. Okay, some equation that can become too complex. And if it's too complex, the calculator just say, oh, I can find value here, I can find value here, oh, under this assumption, I can find value here. The calculator say, oh, I'm not going to work, and they just say that's false. Okay, that can happen. It's not like something ridiculous. It can really happen. So, which means if you use fx and f inverse x to find intersection, most of the time will work and will work perfectly. But some of the time, it's just not going to work. See that case in VCA papers. So, what we'll do here instead, let's think about what kind of equations can become point of intersections between the two graphs. Okay, if you have 1, 2 on that graph, you must have 2, 1 on the other graph. Okay, they never intersect. Have a think about what kind of point will both on the original one and also on the inverse one. When you swap your x, y, that will still be the same point. What kind of graph points can that be? You have two values, you swap them, that will still be the same value. Y equals to x, right? You have 2, 2. After you change the x and y, that's still 2, 2. So that point can both on the original one and also on the inverse one. All the rest of the graph will not be like at the same time to exist, because 1, 2 become 2, 1, 3, 4 become 4, 2. So they never meet each other. Only the point have same x, y values, they will intersect. Okay, that's why the three lines intersect at a point. Can you see y equals to x, f inverse x, and fx? Okay, those three lines must be intersect at the same point, and they all intersect at the point y equals to x. So the intersection must be x, y have the same coordinates. Okay, x, y have the same coordinates. There will be like one exceptions. I will tell you what the exception is. But 99% of the time, and say 99.9% of the time on the VCA papers, that will not be that special case. Okay, will not be that special case. So we have this graph. Okay, we have this graph. So that will intersect at the point y equals to x. So I want to solve them simultaneously with y equals to fx and with the line y equals to x. Why I choose the original function and y equals to x? Because it's easy for me to calculate. And why I choose original instead of inverse? Because you can make mistakes in inverse. Okay, you can calculate something wrong and find, I used the wrong equation and I used y equals to x and I solve out the wrong point of intersection. Instead, if we use the original one and I use y equals to x, I must have the correct point of intersection and I still get marks even though you make mistakes in f inverse. Or you can check your answer. Say, I sketch my graph and I find, oh, my point of intersection is not the point I solved out, which means you find you do something wrong, like in previous steps, and you will go back to check the values. Okay, so we always use f original x, and I will use y equals to x to solve for intersections. So if we solve for intersections, we have 2x minus 3. So we have y equals to 2x minus 3, and I have y equals to x. I want to solve them simultaneously. Then 2x minus 3 must be equals to x. X must be equals to 3. then you don't need to worry about the y. Your y must be 3. Because you solve y equals to x as one of your equation, the x, y values must be the same. You solve out your x, don't need to worry about your y. No need of substitution, y must be that point, otherwise you make mistake. Okay, 3, 3 will be the point of intersections. And we have the point here, 3, 3. Okay, we have the point here, 3, 3. So that's the logic, what I'm trying to do to solve for intersections. And you may ask me, is that like 100% of the time I will have point of intersection here? No, there's 1% of the chance it's not intersects there. What's that case? Okay, what's that case? It's a really special case. Say you have in the original equation, now let's just write it here. In the original equation, you have 2 points. Let's say the 2 points is 1, 0 and 0, 1. So in the inverse, this point will become 0, 1, and that point can become 1, 0. Can you see? Which means in the original graph, I already have inverse pairs, and in that case, I can find intersections. If I can show this on the graph, that will become a case like this. How can I draw this graph? So say I have a graph like this. Okay, that point is 1, 0 and 0, 1. Then the inverse function will be this one. Okay, reflect by the y equals x. And they intersect at here, here, and also here. Which means the function itself is already very special, and then the point of intersections can exist like not really on the line y equals to x, it can exist in other place. But I must have these pairs, okay, I must have pairs. So in the F, the requirement is, in the F, I must have 2 points, which is AB and BA. Okay, AB and BA must both exist in the original function. And after you inverse that, you still have those 2 points, and those 2 points can become the point of intersection. That's a really, really special case, and I think in your exercise there's one such questions. Okay, there's one such questions. So you have BA here, and then you have AB here. Those 2 points will be intersection, those 2 points will be intersections. But it's because those 2 inverse pairs already exist in the original function. That's why after you inverse them, you will have still those 2 values, and they will intersect. Okay, they will be intersections. But that's a really special case. When you sketch your graph, you can see whether I have intersections outside the y equals to x. And if it's not, you just use the thing I just teach here. Okay, y equals fx and y equals x to solve for intersections. It's only 1% of the chance you have the y I talked like at the top. Okay, intersects in other place. Intersects in other place. Okay, so linear is a special case. Let's have a look at quadratic. Okay, first of all, what kind of equation is a quadratic? Like what kind of relation? 1 to 1, many to 1, 1 to many, many to many. What kind of relation is that for a quadratic? Like say we have a quadratic graph. What is a quadratic graph? What's the nature? Is that a 1-to-1 function? How we can test about this a 1-to-1 or 1 to many or many to 1 or many to many? We draw horizontal lines to test about the first word. It touch at 2 points, so that will be a many. And I draw vertical lines. It's all touch at 1 point. That's a many to 1 function. Okay, quadratic is a many to 1 function. If it's a many to 1 function, then I shouldn't find inverse for that. There's no inverse function for a many to 1 function. It's only 1 to 1 can have a 1 to 1 inverse. But what I can do to this question is, I have restricted the domain. Okay, I have restricted the domain. Let's not include the turning point in the domain. Okay, I can only have the half left, left half, or right half. Like I can take halves. And that is a 1-to-1, okay, if I have restricted domain. So let's think about this equation here. My domain is 3 to 6. and fx equals to x over 3 squared, f over 3 squared. So you can see that is a graph like 0, 0 is the turning point. And I have 3 to 6, which means I have point from here to here. Say 3 to 6, I have point. So it's a one-to-one function. And if I want to sketch for that, let's say what f3 equals to. f3 equals to 3 over 3 squared equals to 1. So I will have coordinates 3, 1 here. And what is f6? f6 will be 6 over 3 squared, which equals to 4. Okay, is that 4? Yeah, equals to 4. So I have 6, 4 here. So if I can sketch 3's here, 1's here. So I have this point 3 and 1. And then I'll have a point 6 and 4, which is here. I have 6 and 4. And because that's a quadratic, 4, 1, 9. So I have a graph like this. This graph. Okay, so I have a shape like this. Okay, I have a shape like this. And I have 2 endpoints. Okay, that's the 2 endpoints. Okay, now we try to think about this. This will be reflected by the line y equals to x. Okay, I will sketch out y equals to x first. So that's the line y equals to x. That will be reflected by that line. And have to think, if we have 6, 4 as the endpoints, I must have 4, 6 on the inverse graph. Okay, I must have 4, 6 on the inverse graph. If I have 3, 1, I must have 1, 3. Here. So 1, 3 must be the endpoints and 4, 6 must be the endpoints for the inverse. Because I have nature of endpoints here, I must have those 2 endpoints on the inverse graph as well. And then if I have like reflections, then the graph looks like this. It's quite symmetrical. So I will have this black graph. Okay, I have this black graph. So that will be my fx, and that will be my f inverse x. I need to label the graph, okay? Otherwise, I don't know which one is inverse, which one is original. Okay, so that is the graph, but I haven't worked out the rule yet. So let's write the rule. So step number 1, I will write the domain for original function. So the domain for original function is given. So 3 to 6. Step number 2 is I'm going to write the range for the original function. Okay, on the blue graph, the range is 1 to 4. Can you see that? Because I sketched it already. So it's 1 to 4, which is the range for the blue graph, which is the original. So 1 to 4. Number 3, I will change x to y, change y to x. So I have y equals to x divided by 3 squared. So now I will have x equals to y divided by 3 squared. That's how we find the rule. Okay. Step number 4, I will rearrange the equation to make y to be the subject. So tell me now how we can make y to be the subject. So I must have y equals 3 out. So what y equals to 3 equals to? Anyone? That's really important. You need to know how to work on this. I want you to think, okay? It's okay not answering me, but like you need to think what y equals to 3 will be. Okay? Have a thinking in your mind what that will be. You can square root both sides, right? Because I have something squared, you can square root both sides. But you must have plus minus here and square root of x. Again, if something squared, let's say a squared equals to b. a must be plus minus of square root of b. Okay, a must be plus minus of square root of b, because after square the minus sign can go on. So must be plus minus of square root x. Mathematically, you must have plus minus sign here. So y will be 3 plus minus 3 root x. But plus minus 3 root x will not be correct in the final answer, because you can only choose one rule. You have one rule, the inverse must be one rule as well. You can't have like plus or minus. If you have plus minus, you have like a one-to-many graph. Okay, it's not a one-to-one. Each x can only be corresponding to one y values. If you have plus minus sign here, it can give you 2 values. But it doesn't matter. You must have these steps here. Okay, you must show you can work out to the step. And we need to choose between plus or minus. Okay, I can choose between plus or minus. But I'm not like in a hurry to do this from this stage. I will keep going. I will just leave a question mark here. I need to choose one of that. But I don't know which one to choose yet, but doesn't matter. Keep going. Number 5 will be domain for F inverse. Domain for F inverse, which is the range of F, which is this, is 1 to 4. Step number 6. I'll write range of inverse. From the previous question, the range of F inverse is not helpful. Okay, you just write it there, but you haven't really used it. Now, it's very important. When you have plus or minus and you can't choose between plus or minus, the step number 6 is the key step to help you to decide which one to choose. So range of F inverse will be the domain of F, which is 3 to 6. Okay, now you have your range of F inverse is 3 to 6. Let's look at back to this question. You have range all positive. Can you take negative sign in front? If you have a negative 3 root x, that's all negative values. Doesn't matter what x you have taken, right? It's all negative. But I have all positive range here. I can't have negative range. I must take the positive one. So you write in this step y equals to 3 root x. It's only when you know what is the range of inverse, and then you can come back to decide which one I should take. Okay, which one I should take. Okay, so first important thing is you must write out plus or minus, and then you must decide which one you want to take. Okay, I marked here 12 papers recently, and I see they make mistakes here a lot. Okay, half of the class make mistakes here. They forgot to put plus minus. That's the first half, like why the mistake exists. The second half is they choose the wrong one. They always choose the positive one. It's not always the positive one. It can have the negative one. It depends on your range. Okay, it depends on your range. It's not always positive or always negative. It totally depends on your range. So you must work out your range of inverse first, and then to think about what I should take. So I can write F inverse, domain of F inverse is 1 to 4, mapping to R, comma, F inverse X equals to 3 root X. Okay, so that's for this question. That's the all the 6 steps you need to complete that, and then you choose your correct answer. And we have a similar question for the next one. Okay, we have a similar one next. Okay, I need to finish this one, and they have more practice. We'll give you to practice. So let F36 mapping to R fx equals to that rule. Let's go back to this a little bit. We have a quadratic at the beginning. The inverse is a square root. Can you see that? Your original one is quadratic and you have square root. If you have a cubic function, then the inverse must be a cube root. If you have a linear, the inverse will still be a linear. Okay, so they're all in pairs. Okay, they're all in pairs. If you have hyperbola, that is still a hyperbola. Okay, it's all in pairs. So you need to remember that. Question 4. You have domain 3 to 6 again, and you have this function. So this function, you will have 1, 4 as your turning point, and it's like a graph like that. Roughly sketch, we have a graph like that. And you want to 3 to 6. So you want 3 to 6, which is this red part of the graph, which is a 1-to-1. Okay, first you need to think whether it's 1-to-1, and it is 1-to-1. If it's 1-to-1, which is good, I can find the equation, the graph first. Let's say f3 will equal to 3 minus 1 squared plus 4, and that is 2 squared is 4, 4 plus 4, which is 8. So you have the point 3, 8. So 3 is here, 8 is here. Okay, so you have 3, 8 here. Okay, the next one is f6. So f6 is 6 minus 1 squared plus 4, which is 5 squared is 25 plus 4, which will be 29. 29. You have 6, 29. Okay, 6, 29. So you have 6 here and 29 here, which is a really steep graph like this. You will have 6, 8, 3, 8, 6, 29. Then you must have, let's say, sketch y equals to x. Y equals to x. Then you must have 8, 3. You have 8, 3. And you have 29 and 6. The graph looks like this. That's 29, 6, and that is 8 and 3. So this is your inverse graph, and this is your original graph. Okay, step number 1. Find the domain of f. Domain of f is 3 to 6. Number 2, find the range of f, which is 8 to 29. That's all from your graph. Okay, that's all from your graph. Step number 3, change x to y, change y to x. So x equals to y minus 1 squared plus 4. Step number 4, rearrange the order. So y minus 1 squared equals to x minus 4. Have square equals to something, you square root both sides, have plus minus of square root x minus 4. Y equals to plus minus square root of x minus 4 plus 1. Okay, plus 1. Okay, still question mark here. I don't know which one to take yet. Step number 5. The domain of f inverse will be the range of f will be 8 to 29. Step number 6, which is the range of f inverse equals to domain of f, which is 3 to 6. Okay, now 3 to 6 is all the positive values. Okay, it's all the positive values. And if you choose negative, so if 1 subtract that, you will have all the numbers below than 1. If you have a plus, then you will have numbers greater than 1. So I need to take the number greater than 1 because I have range 3 to 6. So therefore, y needs to be root x minus 6 plus 1. So f inverse can be domain is A to 29, mapping to R, F inverse X is root X minus 4 plus 1.